Everyone. This is Paige Stichler, and this is the Polaris case study. So for the agenda, I'm going to talk about why does Polaris outsource their components. I'm going to show the calculations for the 3 locations, United States, Mexico, and China. I'm going to explain how I came to my optimal solution. I'm going to go through the sensitivity analysis that would show other options, and then some qualitative factors to consider as well. So for why Polaris outsources, there's several reasons why I think they would do this, but for one, it's going to be cheaper to buy some of the smaller, components from overseas, Mexico, China. They just can do most of these things at a lower cost, and then they can aggregate the cost and just buy these parts in bulk from overseas suppliers. Then also by buying the components overseas and then assembling it in the United States, it still allows their product to be considered made in the US, which then allows them to have their business focus be assembling the product itself, the finished product, the design, and that sort of thing. And then they don't have to focus on, how do we produce tires or how do we produce microchips. Like, that's just not what their expertise is in. Their expertise is in the design of the product itself, and they let the other suppliers worry about making all those small components and then sending it to them. But one benefit of vertical integration, where you would be, producing all the small parts yourself and then assembling it, for one, you'd have more control over the quality aspect of it. You're the one making everything start to finish, so you know exactly what you put in is what you're going to get out. And then you also have control over the product line. You have control over the design, any sensitive information. You're not having to give that to a supplier to make part of your product. You have full control over it, so you're not having to share drawings or anything like that with other suppliers. So as far as the calculations go, I had to first start off by finding the exchange rate. So I did a linear forecast, taking just the past 6 years because we didn't want to go too far back. Did a linear forecast, and then that came up with the yuan and pesos exchange rate. Then next is the production costs. For the United States, it was just taking the 400 units, or $400 per unit times 14,500 a year. And for Mexico, it's the same thing. You're going to take, the 4560 per unit times 14,500, but then you're also having to utilize the exchange rate at the bottom, so you got to divide by the 13.41. And same for China. You're just taking the cost per unit and then times how many units a year, and then utilizing the exchange rate. And then I kept it the same for all 5 years because it's saying the production would stay flat for 5 years. Then for the labor costs, I also did a linear forecast. It did give the wage growth rate for 2000 through 2008, but we needed to find the exchange rates for 2011, 12, and through 15. So I did a linear forecast and came up with a number of what it was expected to grow each year. And then I continued on for both China and Mexico so that I could get monthly wage rates for the years that I would need. So here's where I've just added in, this is where it was in 2008, and then I'm adding in what the linear forecast result was to continue that down. So for the labor costs for the US, you're simply just taking the US hourly wage times how many hours they're going to work each year times, that should be the cell below it, but it's the same number. So times 60 people hired. Then for Mexico, you're going to take, they're working 12 months a year. Here's the monthly wage rate for 2011 down at the bottom, and then that you got to use the exchange rate to convert it to US dollars so that you're comparing apples to apples. And then it's 60 people hired. So then you can see the US stays the same, because I'm not using a different wage rate each year. But for Mexico and China, I did find the wage that would increase or decrease each year. And same for China, 12 months a year times the monthly wage rate, utilizing the exchange rate, and there's 60 employees. So then for the transportation costs, first I had to figure out how many trucks would be needed for the US and Mexico. So I just took a roundup of how many units they needed, and there's 26 fit in a unit. And then once I knew how many trucks we needed, I needed to figure out times the mileage, how many miles for in the US times the cost per truck per mile. That gave me those numbers. And then same for with Mexico, it's the same trucks, but it's different mileage, but it's the same cost per truck. So this number changed between the two. So that then gave me these transportation costs for United States and Mexico, same year over year. And then for China, it's simply it's $190 per unit, 26 fit in a container, and then the total number of units is 14,500 for the year. So the 190 times the 14,500 gives you your yearly transportation costs for China. And then for the tariffs, there were no tariffs for the United States and Mexico, so I simply had to find, for China, you just add the production costs and transportation costs together, and you multiply that times the 5% tariff, and that also stayed flat year over year. So the last two things that would need input was the capital investment. There was none for the United States. There was 9.5 million for Mexico and 10 million for China. And then the severance to the US workers, there's no severance if we keep it in the US. And then it's 20,000 per the 60 workers if we moved to China or Mexico. So that's the 1.2 million for either of those. Then everything else was formulas pulling the data in from the other tabs. So then to get the net present cost, I did a formula that looked at all 5 years, including year 0, the NPV, and then I did the 10% discount rate. So I did that for the United States, Mexico, and China. They all used the same 3 formulas. So that gave me these net present costs, 39, 33, and 38 million. If you keep it in the United States, there's obviously, no savings. If you go to Mexico, then there'd be a 5.2 million savings. And if you go to China, just a 800,000 savings. And then I did the match index formula, and, it's saying your most of your savings would come from if you move it to Mexico. So my optimal solution as as everything is laid out, would be Mexico. So I did the sensitivity analysis and I chose just 3 things to see if it would have an impact on my answer. And, with politics and everything going on, there's always a chance that the tariffs could increase from China. And so I just did from 5% to 10%. And, Mexico was already the optimal solution and there is no tariff. So, you can just assume if a tariff increases for China, it's not going to help their case any. Mexico's still going to be probably the optimal solution. But then I did find it interesting that then if the tariffs increase for China, then it's no longer, it was Mexico was the number one, China was number two, and the United States was number three solution. But then it actually would make keeping it in the United States the better option for number two. So then if I also looked at, if their demand went down, if they weren't needing as many units each year, would Mexico still be the best option? And with all the changes that it made, it still was the optimal solution. But again, it did impact China, so that would make them not the second best, it would make them third. And then I was trying to figure out, like, okay, how do we do what needs to happen for Mexico to not be the optimal solution? And essentially, what was hurting China the most was the tariffs compared to Mexico. So I was like, well, what if we add a tariff to Mexico? And I did 3 different options. I tried 4. I did 5%, 10%, 15%, and 20%. And at 5, 10, and 15% tariff, Mexico was still the better option. But then once I got to 20%, that's when the optimal solution finally changed from Mexico to China. And so one thing to look at is just the numbers on paper. What's the cheapest place to make the parts at? But then there's other factors, other qualitative factors to consider. If they did outsource this product, one is that Polaris has kind of built their brand on being an American company. So if they start producing in China or Mexico, how many customers would they lose because those customers are adamant they want a made in US product, versus how many customers wouldn't care. They just want a good product that they like from a brand they know, and they don't really care where it's produced. Another thing to consider is political volatility. Just like with the tariffs, that could change anytime. Same with, anytime there's issues going on in any country, you have to consider all of your components that are coming from there. So even if it's, if it's made in China and you're trying to source your components from, another area, if there's issues there, are you going to be able to get your components? And then also the quality control. If it's assembled in the US, you kind of have the final output is in your control. You get to see and check everything over to make sure it passes your standards. But if you move assembly to, China or Mexico, you're essentially blind in knowing like what the final product going out the door is going to be like, and you're really having to trust, who's manufacturing it, that it meets your standards. And then another thing is just with unpredictable weather. If you have your production in, Mexico, that's not as much an issue because you're still mostly transporting your parts by rail or truck. But if you do move it to China, all the issues getting the containers overseas, getting, into the port, and all the weather delays and that sort of thing, the further you move your production line, the more possibilities you have to consider. And that's it. Thank you.